Hello everyone and welcome back. So we are going to finish this section on doing the graphs of the last two trigonometric functions, mainly the secant and the cosecant. And these are going to be, just like the tangent and cotangent, there's going to be vertical asymptotes involved, and that's because these functions have denominators, which could be zero. But we're also going to see that the shape of the graph is somewhat different, and in fact, these graphs will actually have turning points. So the secant, let me remind you, is the reciprocal of the cotangent, and because the cotangent could be zero, the secant will be undefined someplace. The secant will be undefined where the cosine is zero, and we know that that's precisely at the numbers plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, and so on. Okay, any odd number times any odd multiple of pi over 2, basically. So these will be where the vertical asymptotes are. The period is 2 pi because the period of secant is 2 pi because it's also the period of the cosine, and because of the secant of x plus 2 pi, well, that would just be equal to 1 over the cosine of x plus 2 pi. Okay, and then this would be equal to 1 over cosine of x. Okay, because the cosine is periodic, and then this would just be secant of x. Okay, so the period is 2 pi, and the domain is going to be all numbers, anywhere where we don't have a vertical asymptote. So it would be all real numbers x not equal to an odd number times plus or minus pi over 2. And we're going to see that the range is quite different. The range is going to be from negative infinity to negative 1, and from 1 to infinity. And the reason for that is the cosine, obviously if the cosine is 1 or negative 1, this is just going to be 1 or negative 1. But if the cosine is, let's say, between 0 and 1, then 1 over the cosine is going to be greater than 1. And if the cosine is between negative 1 and 0, then this reciprocal will be a number that's less than negative 1. Okay. So that's why we have the range. And here are some of the values of the secant, at least the ones that we can get from the unit circle. I've listed all the values of the cosine, and then I've given their reciprocals if they exist. Now, of course, the reciprocal 0 doesn't exist, so the secant is undefined at negative pi over 2. Then at negative pi over 3, the cosine is 1/2. The reciprocal is 2. At negative pi over 4, if we take the reciprocal of this and simplify, we get the square root of 2. If we take negative pi over 6, the cosine is root 3, square root 3 over 2. If we flip it and then rationalize the denominator, we get this, 2 square root 3 divided by 3. And then, of course, at 0, the cosine is 1, so the secant is 1. So we can say these numbers actually go from 2 to 1, and at 0, and then all of a sudden they start increasing again. At pi over 6, we're back to 2 square root 3 over 3, and then square root 2, and then it's undefined at pi over 2. Now from pi over 2 to 3 pi over 2, we see that all these values are negative because the cosine is negative. Remember, the cosine is negative in the second and third quadrants, and that's from pi over 2 to 3 pi over 2. Okay, and we see that, for example, 2 pi over 3, the cosine is negative 1/2, so the first reciprocal is negative 2. And we go from negative 2 down to negative 1, and then once we get to pi, these values are increasing. They're still negative, but they're increasing. They go from negative 1 to negative 2, and then keep increasing. And at 3 pi over 2, the secant is undefined. So what does this graph look like then? So, well, if we plot these points, and the most important, let's first label the asymptotes so we have here's negative pi over 2 and pi over 2. And we saw at 0, of course, the value is 1. And all the other values are bigger than 1. And in fact, the graph will look like this, a U-shaped graph like that. Now, between pi over 2 and 3 pi over 2, well, for example, at pi, we can see the value is negative 1. Okay. And we can see that all the values are negative. And they go from like negative something with like from negative 2 to negative 1 and then back to negative 2. So it goes up and then goes down again. So we get a picture like this. And this completes one cycle of the graph of y equals secant x. I probably should label this graph. Okay. And then because the period is 2 pi, then it just repeats. So over here, let's say between 3 pi over 2 and 5 pi over 2, we just get this graph again, this U-shaped thing again at 1. Okay. And then down here from, let's say, negative 3 pi over 2 to negative pi over 2, we have this. Okay, this goes down again, so at negative 1. So, okay, and then this just keeps repeating. Okay. Okay. So that would be the graph of that's the graph of the secant function. So let's look at the graph of the cosecant function. It's almost the same thing, except things are shifted a little bit. So with the cosecant is, of course, that's 1 over sine x, and it's undefined where sine x is 0, and we know that the sine x is 0 when at all the integral multiples of pi, like 0, pi, 2 plus or minus pi, plus or minus 2 pi, and so on. So that's where the vertical asymptotes will be. The period again is 2 pi for the exact same reason, because the sine of x has period 2 pi, so the cosecant of x will have period 2 pi. The domain, of course, is everywhere except all real numbers where we don't have a vertical asymptote, so that will be at all x not equal to an integer times pi. And the range, we'll see, for the same reason as the secant x, the domain is going to be all numbers that are less than or equal to negative 1 or greater than or equal to positive 1, because once again, if sine of x is between negative 1 and 1, then the reciprocal is going to either be bigger than 1 or less than negative 1. And so if we look at here are the values of the sine x, once again from the unit circle, and we take reciprocals, we get the values of cosecant x. At pi over 6, we get the sine is 1/2, and so the reciprocal will be 2, and so on. And you'll see that these values actually are basically the same values that we got for cosecant as for secant x. It's just they're for different x values. Okay, here we're going from 0 to pi over 2. We're going from very large positive numbers to 1, and then from pi over 2 to pi, we're going from 1 to some very large numbers again. So here, all the values are greater than or equal to 1, and then between pi and 2 pi, all the values are negative, and they're going from they're all less than negative 1. Okay, so the graph is going to look like this. Okay, so the graph is, so here's 0, here's pi, here's 2 pi, here's negative pi. Okay, and then so the graph is going to look like this. We plot these. This will be a vertical asymptote as well, and so here's 1. Okay, we get that. We have pi over 2. Okay, And so the graph will look like that. And then from pi to 2 pi, everything's negative, and in particular at 3 pi over 2, the value is -1. And it comes down like this. Okay. And then this just repeats. And so on, like so. Okay, so almost the same thing, except everything's shifted a little bit to the right, or left, depending on your point of view. All right, so this is going to look kind of strange the first time you see it. All right, so let's look at see if we can get a few things together and see if we can plot some of these variations on these functions without using a graphing calculator. All right, so in this first case, when we're graphing y equals minus secant of 2x, we really just want to find the period, the vertical asymptotes, and also whatever maybe we can find the range of this if it's different, and it will be in this case. So the period, that's probably the easiest one. This will be 2 pi divided by whatever the coefficient of x is, just like it is for cosine of x. So we get 2 pi divided by 2, rather. Okay, so this is going to be pi. So that's the period. And where do we get the vertical asymptotes? Well, we want to find where does 2x, where will the cosine of this will be undefined, where the cosine of 2x is 0. Okay. So that happens when 2x is going to be plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, and so on. So if we divide by 2, we get x is equal to plus or minus pi over 4, plus or minus 3 pi over 4, plus or minus 5 pi over 4. Okay, and these will be the vertical asymptotes. All right, so now we can plot these, and really we can start by just plotting the asymptotes at negative pi over 4 and pi over 4. That will be a starting place. All right. Now we want to plot these. So let's just focus on plotting these between these 2 points. We could plot some arbitrary points. Probably the easiest one is to plot the middle point. At 0, we can see at 0 the secant of 0 is 1, but we have a minus sign, so it will actually be -1 here. Okay, and if you plot some other values like negative pi over 8 or pi over 8, you'll see that they'll also be negative. So the graph will look like this from here. And then the next period, the next asymptote is at 3 pi over 4. And let's see, the middle point here, well, that looks like that will be 2 pi over 4 or pi over 2. If we plug that in here, we get the secant of 2 times pi over 2 is the secant of pi, which is 1 over the cosine of pi. The cosine of pi is -1, so the secant will be -1, and put a minus in front of here, that'll be +1. Okay. So now you'll see that all of the graph is above this. Okay. And then the graph just repeats. Okay. And so you can see the domain is going to be the domain, or the range is going to be all the same as the secant of x. Okay, because this 2 doesn't really affect that. Okay. All all right, and then this just repeats. Let's try do something, and if you want to draw a few more cycles, obviously this would be repeated here, and this one would be repeated over here. Let's look at 2 secant of pi x plus 3. Okay, the period will be 2 pi divided by whatever the coefficient is. It's pi here, so that's just going to be 2. Okay, we want to find the vertical asymptote will be where the cosine of pi x is equal to 0. So that means pi x is going to be plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, and so on. So if we divide by pi, the pi's cancel, and we get x is plus or minus 1/2, plus or minus 3/2, plus or minus 5/2, and so on. So that will be where the vertical asymptotes are. Before we graph them, let's just see what the minimum value is. Because of this 2 and the 2 and the 3 change things up a little. We know that when this is 1, when the secant is equal to 1, y is going to be 2 times 1 plus 3, so that'll be 5. And so we can see that y, if the secant is greater than or equal to 1, then y will be greater than or equal to 5. And if the secant is less than or equal to -1, let's say if this is -1, then we have 2 times -1, that's -2 plus 3, that's 1. So that will mean that y is less than, or y is less than or equal to 1. Okay, so that's what this 3 shifts everything up 3 units. So again, we got this because 5 was 2 times 1 plus 3, and this was 2 times -1 plus 3. That's how we got that. So now we can go ahead and plot this. So let's draw the asymptotes first. Here's a 1/2, -1/2, okay, 3/2, if we wanted to include -3/2 over here, we can. But the at 0, I think we can see that this will be 2 times 1 plus 3. That will be 5. And so the graph just shoots up like this. Play around with about a few more points, you'll see what that is. And then over here, let's say halfway between 1/2 and 3/2 is 1. Okay. The secant of pi times 1 is the secant of pi, which is -1. -1 times 2 plus 3, that's 1. So that's the y coordinate here. And then everything is going to be less than 1. So the graph looks like this. Okay. Now, one of the things, we're not going to be concerned about the x-intercepts. It's going to be one of those cases we don't care about the x-intercepts. We care about the asymptotes more than the intercepts in this case. Okay, and then you can just go ahead and repeat. So this was 5 and this was 1. Okay, because that's the range. The range would be from -infinity to 1 and from 5 to +infinity. Okay, let's look at some graphs of the cosecant. If we wanted to graph the cosecant of 3x, once again we'll find the period first. So the period will be 2 pi divided by 3. I think that's pretty straightforward. And the sine we'll have a vertical asymptote when the sine of 3x is 0. Okay, so we want 3x to be 0 or plus or minus pi or plus or minus 2 pi, etc. dividing by 3, we get x equals 0 plus or minus pi over 3 plus or minus 2 pi over 3, and so on. And that's where our asymptotes are. Let's go from 0 to pi over 3, and then maybe if we want to do from pi over 3 to 2 pi over 3, we can do that. By the way, the range, this is just going to the range of y is just going to be the same as the cosecant. So y is still going to be either greater than or equal to 1, or y is going to be less than or equal to negative 1. And maybe we'll go over here. Okay, so this is pi over 3 and negative pi over 3. Okay. So from and then we have a vertical asymptote right here on the y-axis. Halfway between 0 and pi over 3 is pi over 6. And we can see that if we plug pi over 6 in here, we get the cosecant of 3 pi over 6, which is the cosecant of pi over 2, which is 1 over the sine of pi over 2, which is 1. Okay, so we can see that we'll get this point 1 here. And then the graph will be, all the values, you can check that, I'll plot a few more points, but all the graphs will be up here, will be above 1. So there we are. Then the, let's go from negative pi over 6, all the signs are reversed, you know, negative 3 pi over 6 is negative pi over 2, sine of that is negative 1, so the reciprocal of that will be negative 1. So we have this point down here. So we have that. Okay, and then then again it will repeat like so. You'll have a point, curve here, and a curve here, and so on. All right. And then finally, if we wanted to graph this one, we have 3 cosecant of 2x minus 1. First, the period will be 2 pi divided by 2, which is just pi. Okay. And this will be, we'll have a vertical asymptote where the sine of 2x is 0. So we want 2x to be 0 plus or minus pi, plus or minus 2 pi, etc. We divide by 2, we get 0 plus or minus pi over 2, plus or minus 3 pi over 2, and so on. And so this is where the vertical asymptotes are. And what about the range? Well, again, the key here is where is this cosecant of 2x? If this is equal to 1, what do we get? Well, we'll have 3 times 1 minus 1 is 2. And if we have, if this is negative 1, we'll have 3 times negative 1 minus 1, that's negative 4. So we can see that, you know, if this is greater than or equal to 1, then y is going to be greater than or equal to 2. Or if this is less than or equal to negative 1, then this will be less than or equal to negative 4. Okay, so to keep that in mind, we can draw our asymptotes. And they'll be at 0, pi over 2, okay, we'll have another here, maybe we'll have another one here at negative pi over 2, or yeah, negative pi over 2, and we could draw maybe one more here at 3 pi over 2. Okay, this was not necessarily drawn to scale, but okay. So at 0, this is going to be, well, first of all, 0, it's going to be undefined. So let's look if there's a vertical asymptote here. So halfway between 0 and pi over 2 is pi over 4. We multiply that by 2, we get pi over 2. Cosecant of pi over 2 is 1. 3 times 1 minus 1 is 2. So, you have the point here, and then the graph will shoot up like this. Okay, and then let's say at go down here at negative pi over 4. Negative pi over 4 is, we plug that in here, we get negative pi over 2. That will be, cosecant of that will be negative 1. 3 times negative 1 is negative 4. So, there's negative 4. And the point will be right here. And all the values will be negative below that. Okay. Okay. And again, the reason there's more, it's more down here than up here is because of this negative 1. Okay, and the shift of that. Okay, so that's how we get this, and then you could repeat. You can just repeat this over here. I guess I should have drawn this more to scale, I guess. Like that. Okay. All right. So your graphs don't have to be a work of art, just like mine isn't. But what you'll really be asked is to find give the asymptotes, give the range, give the period, and give a somewhat nice sketch of see what's going on. All right. So with that in mind, I bid you good luck on your homework and your quizzes, and I will see you next time.